Hello guys, welcome back to lecture series on linear algebra. Myself Dr. Swapnil Shinde, and we are here back with one of the important example from the consistency of the matrix. Okay, in my previous example guys, I explained to you all standard procedure like steps for finding the consistency of the matrix, and one of the straightforward example without using the rank we found the solution for this matrix. Okay, and now but from today's lecture onward guys, we are going with the rank of matrix and augmented matrix to identify whether matrix is consistent or not. Okay, and accordingly that we are going to find out the solution for our matrix. Okay, so solution for our linear system. Okay, solution, maybe it is a unique solution, maybe infinitely many solution, or maybe no solution exists. So without further ado, let's get dive into our today's lecture. So let's see how we solve the example using the consistency or inconsistency of the matrix. Okay, what we have in example, examine for the consistency, and if this system is consistent, then solve the system. Okay, make sure that we have to solve the system only if system is a consistent, otherwise you don't have to proceed with the solution. Okay, yes, so first of all we have to check whether it is a consistent or not. Okay, mostly we all have learned the concept like when matrix is consistent, when it is not consistent. Okay, let me revise with one concept. If rank of a matrix A which is equal to rank of augmented matrix A over B, if these two are equal, now system is consistent. And if these two are not equal, then system is inconsistent. Okay, make sure that you need to know these two conditions that we are going to apply subsequently over here. Okay, so how to find rank of matrix A, rank of A over B, that one also I have explained in my last lectures. Okay, I'll suggest you all guys go and refer these videos. Okay, so as we are having non-homogeneous system, so let me explain how the non-homogeneous system look like. Okay, x which is equal to b, this one is our non-homogeneous system, and b which is equal to z not equal to null matrix. Always remember that this one is a non-homogeneous system. Okay, yes, so x which is equal to b and b should be a non-zero, then we call it as a null matrix. Okay, yes, so using given linear equation, convert our linear equation into the coefficient matrix, unknown matrix, and the right hand side the constant we have here. Okay, so how we write the coefficient matrix A? All are the coefficient from our unknowns. Okay, first coefficient 1, second coefficient 1, third coefficient -3, first coefficient 4, second coefficient -2, third coefficient 6, first coefficient 15, second coefficient -3, third coefficient -9. Okay, this is our matrix A. Okay, this one is -3, this one is our matrix A. Okay, so we want the matrix X. X means all are the unknown which present in our linear system. Okay, what are the unknown? X, Y, Z. X, Y, Z, these three are the unknowns. Okay, and now we want the matrix B, which is the right hand side. Okay, -1, 8, 21, -1, 8, 21. Okay, see that we got the matrix A, coefficient matrix A, unknown matrix X, and the right hand side constant as a matrix B. Okay, so this one is our non-homogeneous system. Okay, and we have to find out whether this system has solution, or maybe do not have any solution, or maybe which has infinitely many solution. Okay, so let's figure it out. Okay, so we define only with the condition by their rank. Okay, by their rank we define their solution. Okay, in my last lecture I explained to you all complete procedure guys. Okay, how can we define the solution, or how the solution exists. Okay, that I explained in my last lecture. Okay, now for consistency, let me write for consistency. Okay, for consistency we need rank of a matrix A and rank of a matrix A over B. Okay, we want these two values. Okay, so already we are having matrix A, so we want the rank of matrix A and rank of matrix A over B. But what is actually the rank of matrix A over B? It is augmented matrix. it is augmented matrix, so we apply row transformation, column transformation, or maybe some sort of transformation, so we reduce this rank of augmented matrix A over B. Okay, and then we find out the rank of entire matrix A and rank of matrix augmented matrix A over B. Okay, yes, let me write rank of augmented matrix A over B. Okay, rank of augmented matrix A over B, it can be written as, okay, 1 1 minus 3, all the elements from A now, 1 1 minus 3. After that, second row, 4 minus 2 6, 4 minus 2 6. Third row, 15 minus 3 9, over, use this straight line. And B is here minus 1 8 21, minus 1 8 21. Okay, so see that this one is our entire augmented matrix, guys. You don't have to use this two as a different matrix. Now this one is our entire matrix, which is having order 3 rows and 4 columns. Okay, the order of matrix is a 3 by 4. Yes, now what is our task? Okay, our task is to make first element 1, then 0, then 0, then 1, then 0, then 0, then 1, then 0, and then 0. Okay, so do it for this one. We don't have any intention for this column. Okay, so it will be whatever it will be, okay, at the end. But make sure that at the end we have to convert any one of the row or any one of the maybe or more than one row, we have to convert it into the 0 row. Okay, yes, so that we can define the rank of matrix. Okay, yes, so our first task is to make first element 1, but it is already there, we don't need to process with this one. Okay, yes, our next task is that to make this one is 0 and this one is a 0. Okay, so with the help of first one we can make second and third 0. Okay, so we have operation on R2. Okay, what is the operation on R2? We have operation on R2 and operation on R3. Okay, so R2 can be, if you multiply 4 and subtract it from here, we can easily get the 0 here. Okay, so R2 minus 4 times R1. Okay, R2 minus 4 times R1. Okay, again this one, it will give us the 0 here. Okay, again, and we take one more simultaneous operation on R3. What is the operation on R3 can be possible? So operation on R3, R3 minus 15 times R1, 15 times R1. Okay, see that if you multiply 15 here and take it away from that 15, obviously we'll get that 0. Okay, so that one is very easy for writing. Okay, so operation on R2 and R3, so keep R1 as it is. Let me write a rank of A matrix A over B. Okay, this one is the matrix A over B. We are looking for rank later on. Okay, so we are finding the rank. Okay, matrix A over B means augmented matrix A over B we are writing. Okay, yes, okay, so see that operation on R2 R3, R1 keep as it is, 1 1 minus 3 and minus 1. Okay, R1 as it is here. Okay, operation on R2 and R3. Okay, so what operation? R2 minus 4 times R1, 4 minus 4, it goes to 0, minus 2 minus 4, it goes to minus, this one is a minus 2. Okay, and again 4 times here, minus 2 minus 4, it will be minus 6. Okay, and 6 minus 4 12. Okay, 6 plus 12, 6 plus 12, it gives us 18. Okay, yes, and 8 minus 4, it is 8 plus 4 is a 12. Okay, yes, again similar do it on R3, 15 minus 15 times R1, 15 minus 15 0. Okay, minus 3 minus 15 times R1. Okay, minus 3 minus 15, so minus 18. Okay, it is very easy, guys. And 9 minus 15 times minus 3, so it will be 54. Okay, yes, and 21 minus 15 times 1. Okay, that means 21 plus 51. Okay, 15, so it will be 36. Okay, this one is a matrix, augmented matrix A over B. Okay, so our next task, we got it here, 0 0, we found that one. Okay, yes, so in our next task, what we supposed to do? we have to make this one is 1, or if it is possible to take that one to the 1, it is way easier for us. Okay, so how can we make the 1? So we do operation on R2. What is operation on R2? So we divide minus 1 by 6. Okay, so if you divide minus 1 by 6, this is a scalar multiplication to the R2. Okay, so we'll get the matrix, augmented matrix A over B as 1 1 minus 3 1 1 minus 3 minus 1. Okay, so divide minus 1 by 6, 0 minus 1 by 6 into minus 6 is the 1, minus 1 by 6 multiplied by 18. Okay, minus 3. Okay, so 6 3s are 18 and negative sign as it is. Okay, and minus 1 by 6 into 12. Okay, so minus 2. Okay, that R2 I got the 1 over here. Okay, so can I add any other operation so that R3 also can be 0? We try to reduce the element from the R3 as well. If we reduce this one to the smaller element, so it will be like, it is right now it is like little bigger. Okay, we reduce into the smaller. So in this case I divided 1 by 6 or multiply 1 by 6 to this entire row, so that will get the smaller element. Okay, 0 multiplied by 1 by 6, operation on only R3. Okay, so 0 multiplied by 1 by 6 is 0, minus 18 multiplied by 1 by 6. Okay, so minus 6 3 is 18, so minus 3 it will come. Okay, and 1 by 6 into 54. Okay, so 6 9s are 54. Okay, yeah, 6 9s are 54, and 36 by 6. Okay, 6 6s are 36, it will be 6. Okay, so 1 by 6 into 6, 6 6 are 36, 6 9s are 54, and 6 3s are minus 18. Okay, yes, so this one is our augmented matrix, we got it here. Okay, so our next task is that to make this one 0. Okay, we want this one 0, or you can divide by 3, so minus 1, we will get the 3 here and here 2. That one is also easy. Okay, so you can get more simplest form here. Okay, yes. Okay, so let's do some of the operation. Okay, so I want the minus 3 as a 0 here. Okay, so let's make minus 3 as a 0, so it will be easy to define the values. So here we define operation on R3. Okay, R3 means I want minus 3 as a 0. Okay, so minus 3, if we can get the 3 here, so we can easily add. Okay, so we write R3 plus 3 times R2, 3 times R3 plus 3 times R2, obviously it gives us the 0. Okay, yes, so augmented matrix A over B, we write this one as operation on R3, keep R1 R2 as it is, 1 1 minus 3 minus 1. Okay, 0 1 minus 3 minus 2. Okay, R3 plus R2, operation on R3, which is the R3 plus R2, 3 times R2, it will be 0, minus 3 plus 3 times 1 0, 9 plus minus 3 times 3, so my 9 minus 9, it also 0. Okay, 6 plus 3 times R2. Okay, 6 3 to the 6, 6 minus 6 also it gives us the 0. Okay, yes, now see that guys, we got this entire row as a 0. Okay, this one is our required augmented matrix A over B. Okay, so our required augmented matrix, we got the A over B as an entire one row is a 0. Okay, yes, now see that remaining 2 rows. Okay, so what if you are going to change this element from here? So if you're going to change this one here with this, obviously this 0 will change, but we do not want to change this 0, we do not want to change that 1, so obviously we do not have any option further that we can reduce augmented matrix A over B. Okay, yes, it is not possible to reduce this matrix, so we can define easily rank of this matrix. Okay, so tell me the rank of matrix A over B. Rank of matrix A over B means number of non-zero rows into our entire matrix. Okay, this is entire matrix. How many rows here? This one is a row 1, so entire this one we consider row 1, enter this one row 2, enter this one row 3. Okay, this is the augmented matrix, entire matrix A over B. Okay, yes, so we can see that entire row 3 is a 0. Okay, so if entire row 3 is 0 means number of a non-zero row into augmented matrix is a rank, so rank of A over B is a 2. Okay, yes, and Rank of matrix A, we want the rank of A and the rank of A over B. Okay, we are dealing with these two matrices. Okay, so what is the rank of matrix A then? A matrix means you have to consider this matrix only. What we are the A matrix here? This one is the matrix A, this one is matrix B. So after reduction of this matrix, obviously you will get these steps. Okay, instead of finding some another calculation, you can advance this one to here and take the answer from here. Okay, so rank of matrix A means rank of this only this block. Okay, so we can see that number of non-zero row is a 2. That means rank of matrix is a 2. Okay, so we can see that rank of matrix A over B, which is equal to rank of matrix A, which is equal to 2. Okay, so see that guys, we have rank of matrix A over B and rank of matrix A, which is equal to 2. Okay, that means system has a solution. Okay, system has a solution. That means our given system is consistent. System is consistent. Okay, that means has a solution. System has a solution, but we don't know, maybe it is a unique solution, more than one solution, or infinitely many solution. For that we learn in our last lecture. Okay, for that we learn in the last lecture for rank of matrix A, which is equal to rank of matrix A over B, which is smaller than n. Okay, it is smaller than n. N is here order of this matrix. Okay, column of this matrix m by n. Okay, yes, so which is smaller than n. That means rank of A is equal to 2, which is equal to rank of A over B, but which is smaller than n, which is a 3. Okay, n is a 3. Why? Because matrix is having m by n order as a n, which is equal to 3 here. Okay, order of matrix is a m by n and n is a 3 and it is smaller than 3. So that means system has infinitely many solution. System has infinitely many solution. Okay, system has infinitely many solution. So let's figure it out. What are those infinitely many solution for our system? Okay, yes, finding the solution, we are taking this last matrix. Okay, this one is the matrix A, middle X, and this one is the matrix B for finding the infinitely many solution. So guys, see that our last augmented matrix I divided again back to the matrix A and the matrix B again. Okay, and X is an unknown matrix here. So in order to find out the solution, we need this one. Okay, so again we go back to the process. We write A into X, which is equal to B. Okay, so A into X, which is equal to B, so that you will get the value for X, Y, Z. Okay, so 1 into X, which is X, plus 1 into Y plus Y, minus 3 into Z minus 3Z, which is equal to minus 1. Minus 1, I got the first equation. So 0 into X, which is 0, 1 into Y, which is Y, minus 3 into Z minus 3Z, which is equal to minus 2. But last value goes to all are the 0. That means 0 into X plus 0 into Y plus 0 into Z, which is equal to 0. Okay, so see that I got these two equation, but we supposed to get 3 equation. Okay, so until and unless you do not have 3 equation for X, Y, Z, you cannot find out the solution for our given system. Okay, yes, so we don't know the third equation, but maybe third equation in the form of a Z. So we substitute, we consider Z, which is equal to some another variable. I consider Z as a t. We don't know the value for Z. Maybe Z can be anything. Okay, so I consider Z as a value t only. Okay, Z is a t. So if a Z is a t, then replace Z is a t into remaining 2 equation. Okay, so Y minus 3Z is equal to minus 2. We write, we consider this 2, consider 1, consider 3. Okay, put 3 in 2. Put value of Z is equal to t in equation 2. So Y, we write Y which is equal to 3Z minus 2. 3Z minus 2. What I have done, I taken this negative 3Z to the other side. We got the positive 3Z. Okay, so Y is equal to 3Z minus 2. So Y which is equal to 3t minus 2. Okay, so this one is the value for Y. So I got the value for Y is a 3t minus 2. Okay, yes, this one is the value for Y. Similar, we are having value for Z as a t, Y is a 3t minus 2. Okay, similarly put Z and Y into this equation, you will get the value for X. Okay, so we have equation first, this one is third, this one is fourth. Okay, equation first, put equation first. What you substitute? We have to put 4 and 3. Okay, in our equation first we have to put 4 and 3. Okay, z and y put in equation first. Okay, so what is the equation first? X plus y minus 3z, which is equal to minus 1. Okay, yes. What is the y? We don't know the value for x. Okay, so keep x as it is, take y and z to the other side. Okay, so my 3z minus 3z here, plus 3z, plus y minus y, and minus 1 remaining. Okay, so put the value for z and y here. What is the value for z? Is a t. Okay, 3 into t minus, what is the value for y? 3t minus 2, 3t minus 2. Okay, and a minus 1. Okay, solve the further values. Okay, 3t minus 3t plus 2, 3t minus 3t plus 2, minus 1. Okay, so x will be the 3t will be cancelled, 2 minus 1 is 1. Okay, I got the x is 1. Okay, what is the value for x? Is the, what is the value for x? Which is the 1. Okay, yes. So I got the value for x. Now similarly we have to define the value for y and z. Okay, so what is the value for y here? 3t minus 2, 3t minus 2. And what is the value for z? It is a t. We consider z as a t. Okay, because we don't have value for z, so we have to replace some random values. Okay, yes. Now see that this is the value for x, y and z. So in our previous part what we got, system has infinitely many solution. Okay, but how the infinitely many solution look like? See that here. I will show you all the infinitely many solutions. Okay, so see that x is a constant one, that means x is having fixed value. But for y, whenever t changes, y will change. If t is 0, y is minus 2, t is 1, y will be different, t is 2, y will be different. For n value for t, y possesses infinitely many solution. For every value of t, y possesses infinitely many solution, and every value of t, z possesses infinitely many solution. Okay, see that x is a constant, but y and z are having infinitely many solutions. Okay, so I hope you all have understood how the system, how our system having infinitely many solution. Okay, yes. So take this example for your understanding, guys. I will add some more example for your homework. Okay, so you are supposed to follow that homework. Okay, yes, let's do it. Oh guys, at the end, take this 2 example for your homework. Find out the value for x, y, z and comment me in comment section. Okay, I want this solution for the equation example 1 and example 2 in my comment section. Okay, first of all you have to examine consistency of the given linear system, and then if it is a consistent, find out the value for x, y, z and let me know in my comment section. Okay, this one is the entire lecture for us, guys. I hope you all have understood everything, and I want the compulsory solution from each and every one of you guys. Okay, so here we will stop for our today's lecture. I hope you all have understood my today's session, how the infinitely many solution works. I explained here in my today's solution. Okay, yes. So even after, if you have anything difficulty, anything confusing if you found, let me know in comment section, my guys, in my comment section, guys. Okay, yes, I will come up with the similar videos. So that's it for here today's lecture, guys. So thank you everyone, thank you for my today's lecture.